alter this function so that the input and output are switched. Ignoring gravity, graph, then find the position of the pendulum when the car is moving +1 meters per second squared. So I just want to clarify. This is the acceleration of the car. Okay. Again, I always like to make those last parts kind of jam-packed, but first thing we need to do is switch those inputs and those outputs. And before I do that, let's make a distinction here. Cotangent of theta is 1/tangent of theta. We also have something called arctangent, which is just the inverse of tangent. So we can write it either way here. These two are not the same. They're very different, right? Because cotangent is just the reciprocal of tangent. You're not actually doing an inverse, whereas arctangent is the true inverse of tangent. So I feel like people get those mixed up a lot, and I know that I did. So distinction to make there. The question is asking to switch the input and the output. And we know from inverses that when we see words like that, it means that we're taking the inverse. That's the whole point of doing that. So that's what we're going to do. So let's go ahead and write out our function. It's all the way at the top here. We have tangent of theta equals ma/mg. So the m's cancel actually. So tangent of theta equals a/g. G is just a constant. It's 9.81, so we'll multiply it to the other side. So put g here and get rid of it here. So really this is 9.81 tangent of theta, and that's going to equal a. Ta-da! All right, let's go ahead and write it down here. I don't know why it keeps doing that. Hold on. And the reason I did that was so that we had a by itself, and it looked like, you know, the kind of function you would graph. All right. So the question does tell us to ignore gravity, which I know is kind of a stretch, but we want to make our calculations a little more simple. So boom, just destroyed Isaac Newton's life work. All right, there's that. And something we know from inverses is that if we compose them, everything cancels and you'll just be left with a variable. So let's do arctangent of A equals arctangent of tangent of theta. I'm running out of room. So arctangent of tangent, that's composing inverses, so that's going to cancel. And we will be left with arctangent of A equals theta. Okay, so that is our function. And the next thing we need to do is actually graph it so we can find the position. But that sounds kind of complicated. So what we need to do is think about, well, how does arctangent compare to tangent? So we'll use what we know about inverses. Here, I'll go ahead and write it off to the side here. So arctangent of A equals theta, and we have tangent of theta equals A. So we know that inverses have their domains and ranges switched, which is helpful for us. So let's start with tangent. The domain we found was between -90 and 90. I'm writing in degrees right now. And again, we're just kind of doing this from like a conceptual standpoint. And the range of tangent. So in that interval, we saw how when we approached the asymptotes, it went to infinity. So it's going to be from negative infinity to infinity. It's going to be switched for the other one. Big surprise. So the domain is going to be from negative infinity to infinity, and the range is going to be from negative 90 to 90. And that's really going to help us graph this. So let's go ahead and create a graph. Wow. You know, you're given a ruler and you still can't do a straight line. There we go. All right, so range is from negative 90 to 90. So, oh, I am still working with that that line there. Let me change that. All right. So our range is from negative 90 to 90. Okay. And we can actually create asymptotes here. The reason is because if we look at arctangent, we have to think of the acceleration that would have gotten us an angle of 90 degrees. And it's not possible, but you're approaching infinite acceleration. So this is theta, this is acceleration. So yeah, for inverses, you know, we always got to work backwards. But anyways, so we know that the ends of this are going to approach those asymptotes. Let's think about where it crosses the x-axis. If we have an acceleration of 0, the pendulum is not moving, so there's no angle. So we have a point at 0, 0. And then we can connect this. That is our graph. The final thing we need to do is find the position of the pendulum when the car is moving 1 meter per second. So A equals 1 meter per second squared, I mean. All right, so if we plug in 1, so again, working backwards, what is the angle that would have gotten us an acceleration of 1? So in other words, tangent of theta, let's think of it this way, is going to equal 1. And we know that happens when sine and cosine are equal. That is at an angle of 45 degrees or pi over 4. So again, that's where cosine and sine are equal because tangent is sine over cosine. So if we plug in 1 for arctangent, then we know we would have had an angle of 45 degrees. So if 1 is right here, this is not to scale, this would be 45. Right, and so that would be our answer.